Hello everyone, and thank you for joining us for this year's online Beach Lab as part of Robotics Week, which of course has moved online this year. Today for this particular session, I'd like to introduce a range of different small robots that we use as part of the Robotics Club and for outreach activities, but are also suitable if you're interested in having a go at home with some introduction to robots. So I'll be looking at a range of robots laid out here in front of me. I'll show you them as we go, ranging from around sort of £20–30 all the way up to the more expensive robots at about £550. But before I start, I would like to give a dedication of this session to a dear friend who unfortunately recently passed away. He's previously helped with the organisation of running of Robotics Week and a lot of outreach from the university, and a lot of you will probably have known Martin Nels, but he really enjoyed these activities previously, and I'm sure he would have enjoyed it again if he was able to join this year, but unfortunately he's no longer with us. So I'd like to dedicate this to him, and I hope you enjoyed as much as he would have done had he been able to attend. So I'd like to introduce a range of different robots I've got here in front of me. So this here is a BBC MicroBit. It's actually, if I take this out a moment and just to show you. This is a MicroBit microcontroller. And there's the back of it. And you've got a couple of little connectors there on top. It's a robot designed by BBC for actually educational purposes within school, getting kids into programming. And it's a very nice, cheap little microcontroller. You can get this on its own, and you can do a whole range of different things today. But what I'm going to show specifically is this chassis that you can get to go with it. So this is a nice little two-wheel robot chassis, which the MicroBit slots nicely into there. And it's got a range of different sensors built into it. So it's got an infrared sensor on the front for checking how far away things are. And it's got a couple of line following sensors on there. I don't know if you can quite see those there, but there's a couple of sensors there. And there's various different lights, and you can get some other sensors on there. It comes with an ultrasound sensor for a bit more distance ranging finding, but I haven't got that connected at the moment. It's not something I'm currently using for this particular configuration. But there's a whole range of things that you can do with that, and I'll show you that robot running shortly. It's a very nice little starter robot, and I'll also have a look at how we can go about programming this robot and another robot I've got in front of me, because it's very nice and simple, easy to get started with. The next robot I've got here is perhaps one that might be more familiar with a lot of people. This is Lego Mindstorm. This is actually the EV3 version. We use both this version and its predecessor, the NXT, for a lot of our outreach activities, so going out into schools. And a lot of you will probably have had a chance to play around with these in both Sumo and maze navigation at previous Beach Lab events. So this is the EV3. It obviously comes as Lego large kits, and you can rebuild them in a whole range of different designs. They come with quite a lot of different sensors. At the moment, this has only got a couple of sensors attached onto it. There's an infrared that can be used for range finding at the top, and at the bottom we've got a colour sensor there that's currently set up for line following, which gives you a hint as to what some of these robots we will be doing shortly. So it's a very flexible, very versatile robot, and it's very nice and robust, which is particularly important when you're going out and doing outreach, and of course with young children. Building up from there, the next robot I've got is a slightly more sophisticated robot. So this is actually an Elegoo robot car. There's various different models, and these come as kits as well that you can actually buy. This particular one, unlike the others, is a four-wheel robot. And on the top, we've actually got, I don't know how well you'll be able to see it there, but there's an Arduino board, and on top of that board, there's another board for connecting various components together. So at the front, we've got an ultrasound sensor. We've also got an infrared beacon on there for using a remote control with it. But underneath, we've got, in this case, 3 line following sensors. So if I bring that a bit closer, you might be able to see 3 little sensors there, and we can actually calibrate the sensitivity of those as well using this particular variable resistor. Interestingly, the ultrasound on the front is actually mounted on a servo, so it can turn around. So what we can actually do with things like this is quite sophisticated maze navigation, where it drives forward a bit, it turns to have a look around, looks to see which direction is safe to move in, and then it can actually turn and carry on in that direction. Being an Arduino, it's slightly more sophisticated on the programming side, so I won't worry too much about the program on that one, but I will show you the programming of the Lego Mindstorm, and it's pretty much the same for MicroBit. Those three robots have essentially what we call microcontrollers, so when you turn them on, they all run a single program, and they will keep running that program until you actually replace it, until you change the program that's loaded onto them. And actually, before we go any further, I think I'll show you a video of those three robots in operation. So I'm actually going to cheat slightly here. I pre-recorded these because robot demos never go to plan. So please bear with me whilst I just share my screen and show these three robots doing a line following activity. I should say that the line I've got them following is slightly more challenging than the usual line we would get children to follow as part of an outreach activity, but it shows some of the ways in which they operate. So we're going to start off with the Elegoo robot, the most complicated of the three, and set that running. We can see it's actually moving forward and checking for the line. I'll say it's a bit more sharp on the corners, this one, than we would normally go for. You would normally go for quite a nice, gentle line following activity. And this robot actually cheats ever so slightly, doesn't quite make it to the end before turning and coming back again. But this robot would just keep going back and forth continually. It's not going to stop, it's just going to keep looking for a line and keep trying to find it. So it would turn around at that point and carry on. Next we have the Lego. So same sort of idea. And what you'll see is that it's very good at following lines that turn to the left, but it struggles slightly more when it goes to the right. And that's actually because of the algorithm, if you like, for how it's following the line. It's only got a single sensor there at the front, and even with the Elegoo robot, it will turn in a particular direction when it loses the line to see if it can find it, and it will keep turning a particular distance. If you still can't find it, it will then stop and turn back the other way. Now that direction is programmed by me to be to the left. I could have set it to the right. I decided to set it to the left. It actually works slightly better with this line, so that's partly why I chose to turn to the left. And so with the line, if it loses the line to the left, it will find it quite quickly again. But when it's to the right, you have to keep checking in both directions before it's able to pick it up. There's some refinement you could do on the program in order to help it follow the line a bit better, but generally it does a reasonable job. It made it all the way to the end there, and it will actually follow it all the way back to the end, to the starting point. But it will take its time to get there, particularly on that curve. So I'll jump on to the next robot, the final one. And this one, I should say, is my favourite of the three robots. It's speedy, it's efficient, and you can just see it zooming down the line there as it goes. Same sort of principle, that it's scanning in both directions to find the line, but it's actually quite quick and speedy at doing it. Very accurate, and very reliable, actually. And one of the interesting things about these robots is the calibration for, say, the Elegoo robot. You actually have to tune the sensor. It gives you quite a bit of flexibility of tuning the sensor. Similarly with the Mindstorm, you can tune the setting so it picks up just what you want. You'll notice the flooring that I've got there, it's got some quite dark patches on it as well. And so those sometimes cause problems for the other two robots veering off and following the flooring rather than the line that I wanted it to follow. But the Elegoo actually, so the MicroBit was really quite precise. It was very well tuned without any extra work. So very quick, very easy to get going. So what I'd like to quickly do is actually show you the program that we used, or a starting program for getting a robot to follow a line that would work with both the Lego Mindstorm and with the MicroBit, essentially. So I'm going to share a different screen now, hopefully. And this is a setup for the Lego Mindstorm, so it's one of the programming environments. They have two different programming environments that you can use. This is one of the more recent ones that they've developed, but there's also more of a block-based engineering type environment, if you like. But what we can see here is a simulation of the Lego brick on the left. And as we build up a program, it will actually connect motors and sensors to the various ports that we've got. So we can see the two driving motors for the two wheels up at the top. And this is the light sensor that we're using. And actually what we can do is, as I change the light sensor here, you can see that the numbers up at the top for the speeds of the two motors start to change. And if I take it in the other direction, we can see that they're moving in different directions as well. And when we're programming a microcontroller, essentially it's executing a single continuous loop. It's repeating the same action over and over. And this is how we get the scanning behavior. So essentially in each loop, when it's operating, there's two things that we need to do. We need to read the current sensor, see if it's actually detecting a line or not. If it is detecting a line, great, we want to just drive forward. If it's not detecting a line, then we want to change direction. Now, this very simple program essentially does that for us. So it's got the color sensor here. It's looking to see if it's with a particular threshold, so you can adjust how light or dark it needs to be in order to distinguish the line from the background. If it doesn't detect the line, then it's actually going to set the wheels turning in opposite directions. And so then it will actually turn on the spot. In this case, it will just keep turning until it refines the line. So if you've got a straight line, that means it will end up turning around and going back the way it came. If you've got a nice circle, so if you're going around the outside of a circle, then you can actually do that very nicely and carry on going around the outside of the circle until you turn it around to go in the opposite direction on the circle, and it will actually insist on going back the way it prefers to go. So sometimes it's actually, you need to put in a bit more effort there to try and stop it from going too far, and so you do end up with a scanning behaviour. But most of the time, this actually works quite nicely for a simple robot. And of course, if it does find the line, then you can just go straight forward. Now you'll actually notice I've put a slight offset in there between the two wheels, so you'll actually keep veering off in the other direction. But then it will then adjust back when it loses the line, so that can help to compensate for a gently bending line, not perhaps the line I was showing just there. And you can actually build up these. They're very easy to just add more sensors to them. There's motors, different motors as well that you can add there, and it's very easy to use. And if you want to take it a bit further, then you have got the option with this one, for example, of looking at that in the JavaScript, so going to the next level of programming if you like. Okay, so that's, stop sharing that one for a moment. That's the first three robots that I've got there. Moving on from microcontroller-based robots, we've got some slightly more sophisticated robots. So some of you may have heard of the Raspberry Pi. I've got one here just in front of me. It's actually got a pan-tilt camera mounted on top of it, but the bottom board, which you can perhaps see there, is a Raspberry Pi 4. They're on the 4th generation of these computers, and they are actually miniature computers. So this particular one has got 2 gigabytes of RAM. It's got 1.5 gigahertz processor. It's got wireless LAN on it, Bluetooth. It's also got various USBs and Ethernet connectors there. And one of the changes with this particular version is they've got some micro HDMI connectors. So you can plug in an external monitor, you can plug in a keyboard and mouse, but they can also operate without any external peripherals. And it is literally a small computer. You can run an operating system on it. Currently, it's got a flavour of Linux running on there. And on top of that, you can do a whole range of different things with Raspberry Pis, but you can also start to use them to program and build up robots. Now, this one at the moment is configured with a pan tilt servo on top, so we've actually got a 2-axis servo there, and so you can do some panning and tilting. And what you may be able to see there in the middle, there's actually a Pi camera mounted on there as well. So with this, we can actually program up the camera to be able to track objects around, and I'll show you that running in a moment. And just for a bit of fun, as much as anything else, normally this would be mounted on top of the Pi tilt camera as a light, so you can actually shine a light on what it is that you're looking at. This is a NeoPixel. You can actually daisy chain these together, so you can have multiple in a line, and they can be directly connected, or in this case I've got quite a long wire allowing me to move it around and show you. I'm going to try to very quickly show that this is actually really bright, so you won't be able to see a huge amount of colour at full brightness, but if I quickly run this up, you'll get an idea of how bright it can be, to show some of the different range of colours that it can get. I mean, that is really bright at full brightness. I mean, I would not want to be looking directly at that right now, because it is actually quite dazzlingly bright, so I'll take that out of the way a moment. And as I say, what we can do with that is actually use the camera to track an object. And so I've got a little program set up that I will try and show you now. So what I've got is I've set up the NeoPixel to a very pale, lowest level of green light that it can. So what we can see is we can actually detect that, if I get it away from the window, which is far too bright at the moment, and we should be able to detect the green light, and hopefully we can start to see if I can get this into position that is able to track and move the servos around. So that's one example of being able to use that. Now, clearly at the moment this is actually essentially a static demo, so although it can move the pan tilt around, it's not necessarily able to drive around itself. And for most robot applications, we would like that to be able to drive around. So what we can do is we can actually connect the Raspberry Pi to an Arduino. So potentially, if I show you now, we could actually connect the Raspberry Pi to our Elegoo robot. We can use the USB out from the Raspberry Pi and feed into the Elegoo, so we can actually send commands, use the camera there to be able to control and drive around the Elegoo robot. But rather than modifying the Elegoo that we've got there, we've actually got our final robot. I haven't actually got this one up and running at the moment, but I can show you. This is actually quite a complex, sort of the top end, if you like, of the hobby scale robots. It's called Turtlebot. And if I try and bring this a bit closer, what we might be able to see is some things going on. So we've got in there the Raspberry Pi. On the front, we've got a Raspberry Pi camera. And actually on the level below, we have an Arduino on there as well. So the Raspberry Pi is processing the input from the camera. It's also running various other applications on there. On the top, you may be able to see this is actually a laser scanner that's able to detect obstacles at quite a distance. So it's able to construct maps of its environment, for example. It's able to see objects in the environment, and is able to then actually process that information and then provide commands to the Arduino layer, which will then drive the motors to drive the robot around. This laser scanner that we've got on the top, for any of you that perhaps had a look at robot vacuum cleaners, it's interesting to think about how different robot vacuum cleaners actually operate as well. So if you've looked at something like the Roomba, for example, that actually uses a random navigation with bump sensors to just gradually explore. When it bumps into something, it will change direction and it'll keep bumping around. But other examples, such as the Nito robot vacuum cleaners, use these laser scanners to construct maps and build up a model of your living room, of your downstairs, and then plan a path which enables them to explore the entire area as visually as possible, and travel in nice straight lines back and forth. And these laser scanners are essentially what it's using in the top there in order to be able to do that. So that's essentially what I wanted to cover there. I hope you found that informative, and I'll now be taking some questions if you've got any questions about any of these robots. I have to say, I do love these little MicroBits. They're amazingly flexible for what you can do with them. Very easy to program, very easy to get started with, and there's lots of different chassis as well you can put them in, but you don't actually need the chassis. There's lots of things you can do without the chassis. So I would certainly recommend everybody has a go at playing with one of those. Others are available, of course. So thank you very much. I hope you enjoyed that, and hope to see you all soon.